In Chapter 2, we're going to look, as its title says, at some further trigonometry. Now, because further trig is very dependent on these identities that you've learnt so far, all that's happening in exercise 2A is just a review of the identities, and I suppose in particular you're going to see the types of questions that require you to make a connection to these identities. And obviously there will be no instruction that that's what you need to do, that you just have to look at the composition of the question, identify particular things within a question, and then make the connection to the identity. Much of this is then leading into solving some more difficult trig equations. Well, actually that's probably not the right word. Actually, sometimes the trig equations look really, really simple. And it's because they are so simple that you can't substitute for or can't replace them with anything because they're really simple, that we have to put in place a whole nother I suppose step so that we can move forward with a solution. So it seems like really, really simple stuff poses some of the biggest problems. It's not really when you've got things like sine squared and cos squared in an equation to solve, because we've got some understandings of what you could replace sine squared or cos squared or cosec with, and that enables us to get going. So it's these, in fact it is these really simple trig equations where we have to actually make them more complicated before we can actually solve them. Okay, that's enough about what's happening throughout Chapter 2. Lots of new things actually. So this is a nice extension topic. The concepts we'll move on to after this first exercise will definitely be tested. They're things that you will easily recognise in the in an exam. You will definitely be able to see what you need to be using from the extension topics. So what I've done here on this page is just to group them all together for you. I think you know your reciprocal identities well, Pythagorean identities, complementary, and it's pretty obvious when you're going to need to use this, because either you can see 90 minus theta and you can replace it with a simple theta. It's not so obvious sometimes to know when to do the reverse of this. Why would I replace, for example, why would I replace sine of theta with cos of 90 minus theta? Why would I use this identity in reverse? Well, that would only be because I'm heading towards getting a 90 minus theta in maybe a proof question. So I need to introduce it because I can see that it appears later on. I think you would be becoming familiar with the ratio identities. Compound angles, now they're new, but they are on the reference sheet, so that should help with those. And again, they do look fairly obvious when you see these situations in a question, so they become fairly easy to know when to use them. It becomes easy. The double angles, they're the same. So now we've got even another understanding for cos squared. So you see a cos squared, you might want to introduce cos 2a plus sine squared. Or you see 1 minus 2 sine squared, you might want to replace that with cos 2a. There's an endless number of ways they can present a proof question to you such that you need to make a connection back to these identities. I thought this was interesting. Cos squared is this and sine squared is that. And it says here, check out sine squared plus cos squared. So add that, add these. A half and a half is 1. Plus that, minus it is nothing. So you can see that if you do add this up nicely, your cos squared plus your sine squared gives you 1. You'll also see this introduction of triple angle identities, and they're not required to be known as part of this course, but you could actually prove them, which is interesting. So I'll do a couple of those for you, because you really will see this concept of making connections, which you've heard me talk about for a long time. And it doesn't only occur in trigonometry, but you'll see it occur in many other topics as well. So let's get going with some questions. So the first one is prove that sine 3 theta is this 3 sine theta minus 4 sine cube theta. Like I said, that is an identity. However, it's you're not required to know it, but we should be able to prove it. So we know that we would start with the left-hand side and hopefully be able to work it through and get it into the right-hand side. So let me just explain where these 4 lines have come from. So left-hand side, sine 3 theta. Now, there's nothing else I know about 3 theta at the moment except that it could be written as 2 theta plus theta. And if I think about the sine of 2 angles, I know that that can be written as the sine of 2 theta cos theta plus cos 2 theta sine theta. So that's just using this identity here, sine of 2 things, sine the first one, cos plus cos, and then sine. And then sine 2 theta, I can write sine 2 theta as 2 sine theta cos theta. So replace that with this. And then my cos 2 theta sine theta. I've got lots of options for replacing cos 2 theta. I could go with cos squared theta minus sine squared theta, or 1 minus 2 sine squared theta. So at this stage I've got to make a call about which one. So for me to do that, I'm going to go back to and think about where I'm heading. So 3 sine theta, I can't see that anywhere at the moment, but I can definitely see that I want some sine cubes. Now, if I replaced cos 2 theta with a sine squared in there, knowing that I'll be multiplying this bracket all by this sine theta, then that will introduce me some sine cubed. So I'm going to choose that form. So you can see I've put that in. I'm just still going 2 sine theta, simplifying cos times cos to cos squared. 1 times sine theta is sine theta, minus 2 sine cubed theta. So again, just checking where we're heading. We want 3 sine theta and 4 sine cubed theta. I haven't got enough cubed thetas yet, sine cubed. I've only got 2 of them. At this stage, I think I need to do something more here to get some more sine squareds and ultimately sine cubes. So all I've done is I've kept the 2 sine theta and I've replaced cos theta with 1 minus sine squared. I've got a sine theta sitting there and I've got my minus 2 sine cubed. And that works really nicely. Expanding the bracket, you get 2 sine theta minus 2 sine cubes, so that's giving me my additional 2 sine cubes that I needed. Another sine theta and minus 2, Group together your like terms. So 2 sine thetas plus another one is your 3 sine theta. And minus 2 and minus 2 is minus 4 sine cubed theta, which is the right hand side. With question 2, it really is a matter of doing exactly what's suggested here in the small print. So the question says simplify sine of 50 cos 10. It's pretty unusual. And cos of 50 sine of 10. But it suggests that you should look really carefully at this. Well, we've got no other option. I've got to simplify this. So I can only deal with what's given in the question. Is there anything familiar? Well, sine of an angle, sine of A cos B and cos of A sine B, that rings a bell. So hopefully you're thinking, oh yeah, that looks like sine of A minus B. Or is it a cos? What is it? So there is some familiarity with it. What's different? Well, we don't normally have 50 and 10, but I would like to add 50 and 10 because that would give me 60, and I know a lot about sine cos of 60. So if alpha or A was 50 and B was 10, A plus B gives me 60. So I'd really like to be able to replace this with something about in a bracket A plus B or alpha plus beta. Do you recognise any pattern? This is really important, and so much maths is about that. It's being able to see patterns in questions. And that's why I said in the introduction, when there's very little given in the question and there's no obvious pattern, then that's when the questions become a little more difficult. But you're going to be made aware of those situations and know what to connect that to, because we've got to learn some additional techniques. So, and it's saying think about combinations of 50 and 10. Well, that didn't work out quite as elegantly as I would have liked, because the pattern sine cos minus cos sine is definitely sine, and unfortunately it is A minus B. So using that, I recognise it to be sine of 50 minus 10, which is the sine of 40. And we don't know sine of 40. I'd need to look that up. But I feel like I have simplified this. I've simplified that expression down to just sine of one angle. And that's as far as you'd need to go. Now, I think you'll be right to get started with exercise 2A.